Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many ways can 4 baseball players and 3 basketball players be selected from 12 baseball players and 9 basketball players? We see that in this situation, we have 2 different groups. Those are basketball players and baseball players. And from each different group, we are going to take a certain amount or a certain number of players to come up with another group. This is surely under combination, but this is not the same as the previous examples because here we are going to come up with a combination using 2 different groups. So take note, we have a total of 21 players. That's 12 baseball and 9 basketball players. So out from 21, we'll be picking 7, 4 baseball and 3 basketball players. But those 7 are specifically defined that there should be 4 baseball players and 3 basketball players. To do this, as mentioned, we're still going to use the idea of combination using this formula NCR. However, as mentioned, there are 2 different groups. So there would be 2 N's, N sub 1, here I have N sub 2, and there would be 2 R's, R sub 1 and R sub 2. Because there are 2 different groups now, we are going to multiply the the separate combinations to take or to solve for the overall combinations as taking 7 from 21. Okay, if it's only taking 7 from 21, there's no specification of number of baseball or basketball players, then it's just simply 21 taken 7. So it will just be like this supposedly. 21 taken, you will have here 7. But then again, the specifications are defined. So let's start with baseball players. That will be our sub 1s. We all have a total of 12 baseball players. Okay? And we are going to select 4 out of them. As for the basketball players, the N sub 2 and R sub 2, there are 9 basketball players and we would like to take 3 from them to come up with 7 for a total of players taken from 21. So take note that the formula for the combination is in this manner. You have here N factorial over, you have here N minus R factorial times R factorial. But we are going to solve this as a whole as a product of 2 combinations. That would mean the result here is this. Okay? We are going to take the combination of for the baseball 12 C4. You multiply that with whatever be the combination for 9 C3 to get the total number of combinations taking specifications here. So let's start with 12C4. The formula here will have 12 factorial over, of course you have your formula 12 minus 4 factorial times 4 factorial times the second option or second group, you have 9 factorial over, so you have here 9 minus 3 factorial times 3 factorial. I don't know if my spaces are enough. I might extend a little bit later at the bottom, so please bear with me. For our first group, that would mean it's 12 factorial over, you will have your 8 factorial times 4 factorial, and you will know that it's correct because the numerical figure 8 and 4 without the factorial notation, 8 and 4 is equal to 12. Same thing on the other side, you will have here 9 factorial over, we have here 6 factorial, 9 minus 3, and 3 factorial here. So let's start by solving them separately. Let me increase here some space at the bottom. Let me have here, let me decrease this Okay, just like that. Okay, and increase some more here. Please bear with me because I don't have much space, so I'm going to do it like this. Alright, so with this space now, let me go back to the first here, this one here. You will have 12 factorial over 8 factorial times 4 factorial. We know that our factorial notation can be expressed in this manner. Your factorial notation is a condensed way of writing the product of integers 1 to n. So you have n times n minus 1 times n minus 2 until you reach 1. This would mean our 12 factorial here will be written as 12, times 11 times, you'll have here, let me go back to 40 because it's buffering. It's like this one. Sorry. So 12 times 11 times 10 times 9. I will end at 8 factorial because my denominator already contains 8 factorial here. Then I have here 4 factorial. I'm doing this manually, so I could cancel this one here. Okay. Now take note that 4 factorial is 4 times 3 times 2 times 1, which is actually 24. But there's a 12 here. So 4 times 3, I could cancel that. That's 12. Cancel 12 here. 2. 10 has a factor of 2, so I have here 5. And you have here 1. This is so that my denominator now is just 1. It's easier for me to do it like this. I'll add some spaces here. I'll add some spaces at the bottom to finish all of this. Okay, I'll go back to 40%. Okay, therefore, for the first combination for our baseball players, it's just a product of 11 times 5 times 9. Okay, 11 times 5 times 9 here, which will result to 495 combinations. But this is not yet the final answer because it's just one of the portions of this item here. So let's proceed to the next one. Okay, so let's have the 9 factorial over 6 factorial times 3 factorial. The same thing as earlier, I can write 9 factorial as 9 times 8 times 7. I could stop at 6 factorial because my denominator has 6 factorial here times 3 factorial. So I could cancel that there. But take note again, 3 factorial can be written as 3 times 2 times 1. With the factor of 3, 9 can become 3 here as I cancel that one out. And a factor of 8, factor of 2 for 8, which I have 4 here. This would mean that for this result, I have only 3 times 4 times 7 over 1. So I could just simply multiply that. 3 times 4 times 7, I have 84 combinations. But this is again the combination for the basketball players alone. Going back to our problem, we simply plug in these results. You have 495 for the 12 taken 4 times, you're going to have here 84 for your 9 taken 3. The product of this is now your answer for the problem, which gives us a result of 495 times 84 is 41,580 possible combinations. This is the answer to our problem, as this is the number of ways that we can select 4 baseball players and 3 basketball players from a pool of 12 baseball and 9 basketball players. Take note, it's very different from this, because if you will just have simply 21 taken C, okay, if you're going to try your calculators with that, you will have here 116,280 combinations if it's simply 21 taken 7. But because of the specifications that there should be 4 baseball and 3 basketball players, we trimmed it down to this one here. Because for 21, taken 7, it is possible to select 7 basketball players with 0 baseball players or 7 baseball players with 0 basketball players. But this time, it's specified to have 4 baseball and 3 basketball players. It's very long because this time you are having combinations with groupings. So this is how we answer this problem, and that's Count It In. Talking about getting the luck of the draw. For all in, subscribe now.